Hi, in this demo, we're going to take a look at VMware SD-WAN Business Policy Enhanced Visibility utilizing vRealize Network Insight. In vRealize Network Insight 5.2, we've added some additional features that allow you to have visibility around business policy consumption and also have the visibility into how each application is performing over each WAN link connected to the VeloCloud Edge. In this case, in this demo, I will be focusing on our VeloCloud Edge deployed at our Detroit branch. I have this opened up already within vRealize Network Insight. We can see a summary overview of our Edge in regards to any open events, the uptime. We can see that we have 53 applications that are currently traversing this Edge at the Detroit branch. We have 2 WAN links connected, one being our MPLS circuit and the other being our Internet Service Provider circuit provided by Spectrum Internet. We can also see that we have our business policies. Now, as I mentioned in the blog, our business policies are an enhanced mechanism of allowing the Edge to apply quality of service, and this is actually configured within the VMware SD-WAN orchestrator. This is going to allow the Edge to optimize application behavior, driving queuing, bandwidth utilization, link steering, and mitigation of network errors. You'll hear the term DMPO or Dynamic Multipath Optimization in conjunction with business policies. If you want to learn more about business policies and Dynamic Multipath Optimization configuration within the VMware SD-WAN orchestrator, you can see the link that I have posted in the blog for more detailed information. Here we're going to look at our Edge, again, within our Detroit branch, and we can see our business policies. So currently we have 28 business policies applied to this specific Edge at the Detroit branch. What we gain in visibility around business policies in vRealize Network Insight is we have the ability to see which business policies are in use and which business policies are not in use, along with the overall applied business policies that are applied to the Edge. This becomes powerful when we're looking at to see how specific applications are performing that are associated to specific business policies, and also to see if we need to fine-tune the policy to either increase optimization of that application or do some traffic rate limiting utilizing the business policy. Now, if I go over here and I click on the overall business policies that are applied to the Edge, this is now going to show me the total business policies that are now applied to the specific Edge at our Detroit branch. So we can see we have various business policies that are applied. Well, we also notice that we can see that there's only 16 of the 28 policies in use, and 12 of them are not in use. And this is because we are actually seeing, based on flows that are occurring across the SD-WAN Edge, we have the capability of determining which business policies are being used on each individual flow. So let's focus in on the business policies that are in use. Here we can see the various business policies that are used at our Detroit branch. One of the things I'm going to do is let me expand upon our business policies, and we're going to focus on 2 different applications in this demo. So we have an application running in our data center called Hive Media. This Hive Media application is a homegrown training application that is accessed by employees within the company. Now, we can see that we have a business policy that's applied called Hive. If I expand upon this, we can see how the policy is configured. We can see the profile that it's assigned to, the segment. We can see the application that is associated with this business policy. We can see the priority of the traffic, which is high. We can see the service class. We can see the link. So this is going to be our link steering. This is actually set to auto. And we can see the route, which is set via gateway. Now, within the VMware SD-WAN orchestrator, there are predefined business policies that will utilize and recognize the most popular applications out in the world today that end users are accessing. You can also have your homegrown applications that live in your data center or in the cloud that you're running depending on the business type. For these homegrown applications, you may want to go in and configure and add your own business policy specific to that specific application and configure the priority, the traffic or service class, the link steering, and also the routing. So in this case, being that this Hive Media is a homegrown application, we have a custom policy that is applied, and this is our Hive policy that we're looking at. So this is a way that we can look at the various policies, again, that are applied to the VeloCloud Edge, in this case, at our Detroit branch. Now what we can do is we can click on our specific policy, And what this is going to do is this is now going to open up and it's going to show me how the policy is configured. So we can see the definition match and the definition action. So we can see it's source any, destination any, the application being Hive Media, it's applied to the global segment. We can see the route type, the link type, the route, the service class, the priority, and the profile that this is assigned to. We can also see any events that may have occurred over the last 3 months regarding the specific business policy. We also see all of the active flows that are touching this business policy. So here we can see that we actually have a flow from an end user at our Detroit branch communicating with our Hive video server, which happens to be the front end of our application hosted in our data center. Let me go ahead and expand upon this flow. So here we have an overview of the total traffic flow and traffic rate of this connection between the end user and the front end of this application, which happens to be VM-based hosted inside the data center. So we get important information such as the source IP, the destination IP. We're going to see different things like the destination port range and port protocol that's being utilized. You're going to see your destination VM and other important information in path between the end user at our Detroit branch and our Hive video server, which is the front end of our Hive media training application running in our data center. More importantly, what you're going to notice here is the applied SD-WAN policies. So here we can see that we have the policy Hive, which we just viewed, is actually being utilized by the Detroit branch for this flow with the traffic priority of high and a link steering of round robin. Now, one thing we notice here is, and this becomes important, especially as you're applying business policies across all of your edges, is making sure that you have policy consistency. So what I'm seeing here is that our policy web is actually being utilized for this flow at the Washington data center with a traffic priority of normal and a link steering of round robin. So this provides me a clear indication that the Hive policy has not been applied to the Washington data center edge, and that's why we're seeing this web policy coming up. It's interpreting this flow as actually web traffic. This is an inconsistency, and it's also going to treat the traffic differently, being this is web traffic. This is a custom policy for our homegrown application. As we can see, the traffic priorities are different. One is set to high and one is set to normal. So I would want to go into my VMware SD-WAN orchestrator and make a modification and make sure that the proper policy, in this case, the Hive policy for the Hive media application, is applied to the Washington data center to ensure consistency at the source and destination to ensure that we're treating traffic properly, utilizing the proper business policy. Next, let's go back to our Detroit branch. Now, the other thing that I wanted to focus on that's very important is we can take a look at our link application distribution. And for this demo, what we'll do is we'll focus in on two specific applications just to show you the difference on how business policy is being applied and DMPO is being applied across the various links and applying to the various applications that we're going to look at. So what I'm going to do is I'm going to add a filter. Let's filter down on two different applications. We'll filter down on our homegrown application, which is called Hive Media. We're also going to filter down on a second application, which is another popular media application called Spotify. So here we're focusing on two specific applications. So here we can see here on our link application traffic, we can see that at our Detroit branch, utilizing our Spectrum Internet Service Provider link, which is connected to Gig Ethernet 3 on our Detroit branch edge, the Hive Media application, we can see how it's performing from a total packet and total byte from a throughput perspective. So we can see the various throughput for this specific application for the end user at the Detroit branch or end users that are accessing this specific application. More importantly, what we can see is that we actually have a second link here for that our Hive Media application is utilizing. So this is at the Detroit branch, but however, this is our MPLS link connected to Gig Ethernet 4. And again, this is our Hive Media application. So we can now see how the actual business policy being applied, being that this is a homegrown application running in the data center, is load balancing across the ISP Internet Service Provider link from Spectrum and our MPLS link. So we can see the various traffic distributions, and we can see how it's actually utilizing those two links to actually steer the traffic across the links. Now keep in mind, it is also monitoring those links for performance, including latency, jitter, packet loss, and so on. Based on the performance of the link, the edge will utilize dynamic multipath optimization, or DMPO, to choose which links to steer packets over for application performance to meet the proper application performance defined by the business policy. Now, if we look further down and we focus on our Spotify application, we can see Detroit branch, the Spectrum Internet Service Provider link connected to Gig Ethernet 3 for the Spotify app, and then we can see our Detroit branch MPLS Gig Ethernet 4 for Spotify. Now, as you'll notice, Spotify is a popular streaming media application. So in this case, we can see that the media application is utilizing the business policy to steer all traffic over the ISP link and no traffic over our MPLS link, which is what we typically would want, because we don't want end users streaming music or unnecessary media over our MPLS links and consuming up the bandwidth. We'd rather them utilize the internet service provider link in most cases, because this is a lower priority traffic. So this is a case showing you exactly how the total packets and total bytes from a throughput perspective are influenced by business policies and dynamic multipath optimization within the VeloCloud Edge. Now let's look at this at even a more deeper perspective. So let's look at the link application packet, and let's focus in again on those same two applications. So here I'm going to choose our Hive Media homegrown application, and then I'm also going to focus in on Spotify. Now here is another view that gives us analysis of how are these links performing, or how is the traffic performing across the edge. And what we see here are the retransmitted packets, the replicated packets, both on transmit and receive side, and the total packets that are going across the link. So here I can see my Hive Media application on my ISP link, Internet Service Provider link for Spectrum Internet on Gig Ethernet 3, and I can also see that same Hive Media application that's traversing our MPLS link connected to the same edge on Gig Ethernet 4. So we can see the differences on how it's actually performing, and we can see that when we've had retransmitted packets, and then we can also see our total packet throughput, and we haven't had any replicated packets, which is a good sign. So here's where we can analyze and see how they're performing. The application is performing as it's traversing both the MPLS and the Spectrum ISP link. Now, as we go down further, let's take a look at our Spotify app. So again, as we notify with our Spotify app is utilizing the ISP Spectrum link connected to Gig Ethernet 3, but is not utilizing the MPLS link, which is proper in this case because the SD-WAN application, being Spotify, would utilize a business policy that's going to steer the traffic over the ISP link rather than consuming our MPLS link. So here we can see the detailed information around how that actual application from a Spotify perspective is performing with any retransmitted packets, replicated packets, and total packets. So as you can see, business policy visibility, being able to understand which applications are traversing which link, whether it be an ISP link or an MPLS link or even an LTE link connected to our edge. And this gives us that deep analytics that we need to see how the application is performing, and also can give us an insight if we start to see performance issues. We can look at this and determine and do troubleshooting. We can also utilize this to fine-tune our business policies, if we're doing things like rate limiting on the application or adjusting the QoS policy on that application. A lot of that's going to be done specifically when you're dealing with a lot of your homegrown applications running in your data center or in the cloud. You're going to make those fine-tuned adjustments. I hope you found this demo informative, and thank you for watching.